Palma radio, Palma radio, Palma radio. My main engine breakdown. The ship is not under command. The ship is not under command. My position is 2 miles.
A ship without its main engine is a raft drifting in the sea. An engine with a clogged up fuel line is a useless piece of steel. Then why is it that so little attention is paid to the correct practice of bunkering on board some ships? Are you surprised by this question? Do the owners of your vessel order your bunkers on the basis of optimum specification for your engine, or on the basis of the cheapest price? When was the last time you checked the levels in the tanks on the bunker barge before and after bunkering? When was the last time you checked how samples were obtained? Do you always segregate bunkers? Do you test your bunkers for compatibility before mixing them? All these questions must have the right answers before anyone can say that the fate of the main engine and the ship is safe under their care. For this reason, it is most important to follow good bunkering practice. You can take bunkers from shore tanks or have them delivered to your vessel by barge. Fortunately, good bunkering applies to both methods equally, so we will take you through the correct bunkering procedure in the case of barge delivery. But before a barge is on its way to your ship to deliver the bunkers ordered, a number of very important things should have taken place. The chief engineer has checked his bunkering needs in line with the recommended BS or ISO specification by the engine manufacturers for his engine, or laid down by the charter party, and verified this with the master. He has also consulted the mate about the sequence of filling tanks to maintain stability. Knowing the bunkers he currently has on board, knowing the location for his next bunkering and the type of fuel he may be supplied with there, he has made up his order ready to be faxed to head office for processing. The last two factors are important because they allow the chief engineer to assess the chances of obtaining fuel compatibility and quality. The chief engineer wants to have the optimum specification for his engine, not simply to get optimum performance from it, which is important enough, but also to keep maintenance costs down and engine downtime as short as possible. Buying on cheapest price, as some companies and charterers do, is asking for trouble and invariably turns out to be the expensive option. In some ports, ordering very cheap heavy fuel oil can give the chief engineer considerable handling and compatibility problems. These bunkers may be of dubious origin and blend. As a precaution, bunkers should be ordered to a specification which the physical supplier can be contracted to meet. Although this will eliminate the cheaper suppliers, the chief engineer can be sure that he has obtained suitable bunkers at the most economical cost. The best way to order is in accordance with BSMA and ISO specification.
Check deal, we're ready to start.
If head office has ordered the correct grade of bunkers for the ship, it is now the duty of the chief engineer to check the bunker's requisition form with the barge master.
And the second piece of paperwork is just the actual quantity with your specific gravity and temperature there.
Right. And if you have 801 tons there.
Yeah.
Right.
Items that must be verified are that the bunkers ordered are those the ship normally uses,
Okay, right.
that the bunkers delivered are those ordered by specification, and that the correct quantity has been ordered. So what have we done so far to ensure that our main engine will work properly and reliably? We have checked that the correct grade of fuel has been ordered. We have checked that the fuel on the barge is the grade ordered. We have checked that the quantity on the requisition sheet is the correct one. But has the barge got the correct quantity on board? To find out, the chief engineer himself or his nominee should check the barge tanks before delivery as well as after delivery.
Yes, hello, second. Can you go and check the ullages on the bunker barge? Yeah, thank you.
The ship's staff are always invited to inspect the tanks prior to delivery, and if they decline, any subsequent dispute about short delivery can easily be defended by the supplier. For this reason, the quantity inspection should always be done and noted on the form. Whilst the barge tanks are being checked, the chief engineer will agree with the barge master the rate of pumping at the beginning and the maximum permitted rate of transfer. The pressure at which pumping will take place must also be agreed. Overpressure can result in a burst hose, pollution of harbour and consequent heavy fines. He will also agree with the barge master the means of communication and the specific signals used for stopping the pumps at the completion of delivery and in an emergency. These two aspects are most important to avoid any possible spillage due to delay in stopping the pumps. The chief engineer's nominee checks the quantity by one of two methods. If a meter is fitted, the delivered quantity will be calculated as the difference between the reading before delivery and after delivery. Alternatively, a dip tape is used to measure fuel level both before and after delivery, and the quantities are calculated by reference to a calibration chart.
0720.
What happens if there's a dispute arising from a breakdown which involves fuel quality? The possibility of such an event must be anticipated. For this reason, it is most important to ensure that the samples taken during delivery are representative of the fuel delivered.
So you're happy with that?
The recommended method of sample taking is the continuous drip system, which takes samples throughout the delivery period. A modern method of obtaining high-integrity samples is provided by an automatic adequate quality level or AQL sampler, seen here in action. The normal procedure is that 3 1-litre containers are filled flow proportionately through the batch with the sample fuel and sealed immediately, as we shall see, after the completion of delivery. The AQL sampler is set in accordance with the bunker's quantity to be delivered and is sealed against tampering before delivery commences. On occasions, when no empty tank is available for receiving the fuel and it must be mixed with others on board, compatibility problems may arise. Beware, mixing 2 bunkers which are incompatible can result in a useless mass of sludge and an idle main engine. So, a small sample is taken on board to carry out a compatibility test prior to accepting delivery. There are a number of different methods available for testing compatibility on board. Invariably, a spot test is used in this situation in accordance with manufacturer's instructions. The critical factor with these tests is the sample integrity. An unrepresentative sample will always give an unreliable result. While the necessary tests are done, it is advisable to double-check the availability of capacity for taking the bunkers in the quantity requested. An important detail, the scupper plugs must be in place. It has been known that the estimated capacity was incorrect and the tanks filled before delivery was completed, resulting in serious overflow and a major clean-up operation. Delivery begins by the hose being secured to the manifold of the ship. This should always be done under supervision. Most ships provide some sort of drip tray arrangement around the area of the manifold, so that any oil that escapes when the hose is being connected or disconnected can be contained and cleaned away effectively. Check that a good seal has been achieved and that the flanges are tightly secured.
As soon as we give a seal clear.
The hose having been securely connected, all the valves must be opened to the bunker tank receiving the fuel. These valves must not be shut before pumping has been stopped.
Chief to engine room.
Even in an emergency. Only when all these points have been checked and found satisfactory should delivery be authorized by the chief engineer or his nominee.
Yes, we're all clear.
Ready to start bunkers, ready to start bunkers. Okay. Yep.
Ready to start. Okay. Pumping now.
After thoroughly checking all the important details of bunkering prior to delivery, the long, laborious process of transferring tons of bunkers begins. All is well. Or is it? What happens if, as a result of a mistake, one of the valves is closed? A disaster. Or that would be the case if the bunkering station on the ship and the barge were left unattended. Whilst an accident may not be avoided, leaving the manifold unattended is a serious dereliction of duty. If such a disaster should occur, this must be treated as an emergency. The pumping must be stopped immediately, and the oil should be contained before it becomes a spill. If this happens anywhere near shore or in a harbour, the shore authorities must be informed and help sought to contain the environmental damage. That is why someone must always be left in attendance throughout the bunkering process. Occasionally, the surrounding waters should be surveyed in case an undetected spill is in progress.
Okay, Derek.
During the transfer, the tank capacities must be checked to ensure that an overflow is avoided.
If you'd like to call them on deck and tell the bunker barge to slow down. Okay.
If any mistakes come to light in measuring the available tank capacity, either the pumping must be stopped or another tank must be connected in good time. Tanks must be filled in the correct order to maintain stability. To ensure that these tasks can be done, good communication links must be in place between the engine room and the bunkering station, as well as between the ship and the barge.
Down in the pumping rate, please.
Tell the barge to slow down, okay? Tell the barge to slow down, will do.
Thank you.
Towards the end of delivery, contact with the barge should be re-established, and the barge warned to stand by to slow down the delivery at least 15 minutes before stoppage. Remember, a tank must not be filled to more than 95% of its capacity. There is a gradual slowdown of delivery before the pumps are stopped.
Bunker's finished.
At this point, the ship's personnel must check the barge tank levels or the meter reading to verify the actual quantity delivered.
That's 12 centimetres.
Afternoon again, Chief. Completed bunkering now. Just put you the paperwork to sign.
This is agreed with the barge master, and the form is countersigned.
I think we're happy with the figures on that. We seem to have the same amount. Yes, bunker's successful.
The sealing of the sample bottles and their labelling must be witnessed by the ship's personnel. It is vital in the event of a dispute that the sample is the correct one and that it has not been contaminated or tampered with. One of the samples is then taken by the ship and held for at least 3 months in a safe place. Some companies are taking the extra care not to use this fuel until the test results are returned to them from an officially recognized testing agency. This was a successful bunkering procedure. All that remains to be done is to disconnect and drain the hose, seal the manifold, and clear away any spilled oil. So, what were the key elements of successful bunkering? Verifying the grade and quantities ordered, as well as compatibility. Checking barge ullages before and after delivery. Agreeing the communication methods between barge and the ship. Agreeing the pressure and rate of delivery. Slowing down delivery in good time. Obtaining good representative samples of the delivered fuel. The chief engineer can now be sure that at least as far as the bunkers are concerned, his crew have ensured that the main engine will perform exactly as required.